Alright, so today we're going to be doing 13.4, which is graphing inequalities. So here's some important information you need to know about graphing inequalities. You're either going to use a solid line or a dashed line. You use a solid line anytime you have less than or equal to or greater than or equal to. So essentially anytime there's a line underneath the inequality, that indicates the equals as well. Next thing is we have, of course, the dashed and dotted line. The dashed and dotted line occur when we don't have the equal sign under the inequality. And then lastly is if we're shading above or below. So we shade below the line when it's less than, so if it's less than or equal to or less than, and we shade above the line when it's greater than or equal to or just greater than. We can also use a test point to help us determine if we're shading above or below. A good test point is usually 0, 0. Alright, so let's go ahead and do the first problem together. So as you can see, we're graphing a linear inequality. So do you all remember the form y equals mx plus b? You all remember that formula? So this is the same setup when we're dealing with an inequality. Of course, this is an inequality instead of an equals, but everything else is the same. Does anyone remember what the b represents?
The y-intercept.
The y-intercept, good. So this is your y-intercept, which means you are going to start by plotting a point at 3. And then the coefficient of x represents what? The slope. So our slope is -1. We can make it into a fraction by putting it over 1. So this is our rise over run. So if our rise is negative, instead of going up, we're going to go down 1, over 1. You always go to the right. Of course, you can get points on the left by just doing the opposite. So you're going to get a couple points until you have a pretty good idea of what it looks like. And then, as you can see here, the inequality has an equal sign underneath, so is it going to be solid or dashed? Solid. So then you're going to just go ahead and connect the line. Oh, I have the dashed one out. There we go.
Wait, how do you know if it's dashed or solid?
If it has an equal sign under the inequality, like the line, it's solid, and if it doesn't, it's dashed.
Okay.
The way I remember is this uses more ink to write, so does this. So y is less than, so it's going to be shaded below. Okay. So the way you can help determine that is, I think of it like an alligator. Okay, the alligator eats the y, has to come out of the water above the line. So like this. Kind of silly, but it helps. Another way you can verify that you shaded it the right way. So say you get on the test, you can start panicking, I forget if I shaded the right way. Here's what you can do to check. You can simply take the point 0, 0. The point 0, 0 is supposed to be part of our set, correct? Because it's shaded. So we can just plug in 0, 0 into my inequality and verify it. Is 0 less than or equal to 3? Is that a true statement? Yes. So it makes sense that it's shaded there. Okay, so that's a way you can just verify to make sure you've shaded correctly. Does everybody understand how that works? Okay. All right, let's do example 2. Oh wait, we're still got example 1b, my bad. So this is another linear equation. We're going to start by graphing on our y-intercept. And as you can see, our slope is 2 over 1. So we're going to go up 2 and over 1. You're going to do that a few times until you have sufficient points to make the line. Once you have that, we're going to determine if we're going to use a dashed or solid line. What do you guys think? Dashed. Dashed line. So just do the best you can with it with pencil, of course. Just don't forget to put the arrowheads on there. That's important. Lastly, we determine if it's shaded above or below. What do you guys think? Above, because y is being eaten by the alligator, so we shade above. Now, something I was talking about with my coworker is sometimes people get confused what above or below is, because when the line's really like slanted. So keep in mind, when we're talking about y is greater than, we're always going to shade where the y values are greater. So see how here, these are the lower y values, these are the higher y values. I'm shading to fill in the higher y values. And once again, you could also do the 0, 0 check to verify that it is a solution to that inequality. Okay? All right, so now we're going to go ahead and do some quadratic ones. So example 2. So in order to graph a quadratic, I know you've graphed quadratics in this class many times, but just a refresher, a few different ways you can go about it. Remember the formula x equals negative b over 2a? Does anyone remember what that finds? The axis of symmetry, which is the x coordinate of the, it starts with a v, vertex. So we're going to find the x coordinate of the vertex, which is also always going to be the middle of my table, okay? So that's going to be negative 6 over 2 times 1, which is what? Negative 3. So negative 3 is going to be the middle x in your table. And then you can simply just pick some values that are smaller and then that are greater. And then you're just going to plug all of these values into the function. But do you all remember that these two are going to be the same? And these two are going to be the same as well? Maybe you remember, maybe not. So if I plug in negative 3, I get 9 minus 18, which is negative 9 plus 8 is negative 1. If I plug in negative 2, I get 4 minus 12, which is negative 8 plus 8 is 0. So these two are 0. If I plug in negative 1, I get 1 minus 6, which is negative 5, plus 8 is 3. So you can also, of course, use a calculator if you don't feel comfortable doing it in your head. And then I'm going to plot all of these points. And connect. Don't forget to put arrowheads. It's a pretty good rule of thumb when you're graphing a quadratic to always have at least 5 points. Yes?
Wait, so why'd you start like on the x's? Why'd you start at negative 5?
Oh, so you don't start at negative 5. Do you see how I used this formula to tell me what the middle value is in my table? So that one's always going to be the one in the middle. So then to find the other ones, you just go back to and then pick 2 bigger ones.
Yes.
Any other questions about it? Okay. So I graphed it, and I was able to do that because this is solid, right? Because there's no dashed line here. Now, am I going to shade above or below here? It's a greater than, so I'm going to shade above. So above is actually going to be like inside of the quadratic. That's above the line. If it's below, in this case, it's going to be on the outside. So any questions about this one? Okay. So the next example we're looking at here is another quadratic. Depending on how comfortable you are, you probably can tell what some of these look like. I'm going to use the formula negative b over 2a. What is my b in this case? 0. So this is just 0 over 2, which is once again 0. So I know that the middle of my table is going to be 0 for the x. Like that. And then I would plug 0 in, of course. I get some more values in my table. 0 minus 4 is negative 4. And then 1 I plug in, I get negative 3. And then if I plug in 2, I get 0. Right? Now I'm going to plot these points. And it always should have a look of symmetry over that axis of symmetry. If it doesn't, you know something went wrong. And why am I making this dashed instead of solid? Very good. There's no line under the equal sign. And then I have to determine which way I'm shading. So if it's less than, that means I'm going to be shading below. So that means on the outside here. Like that. Any questions about that? Yes.
Where did the 0 come from? Like the first 0?
Like how did I know b was 0?
Yeah.
See how there's no like plain x term in the quadratic?
Oh, yeah.
So technically it's just 0x. Any other questions? Okay. Alright. This one here, I start by doing x equals negative b over 2a, which gives me negative 2. That's always going to be the middle of my table. I can then plug 2 back in, or negative 2 back in. So when I plug in negative 2, it's going to become squared, so it's going to become positive, so it's going to become 4, but then it's going to be negative again. So it's going to be negative 4 plus 8 minus 3, which is going to be 1. If I plug in regular 1, or negative 1, I get negative 1 plus 4 minus 3, which is 3 minus 3, which is 0. And then if I plug in 0, of course, these both become 0, and it just leaves me with negative 3. And then I can plot it. And this makes sense because this is a negative, has a negative a value, which means I knew it was going to be upside down quadratic. So everybody see why we knew that ahead of time? That it was going to be frowny face? Because the leading coefficient is negative. That's just a rule of quadratics. In addition to that, some other things that are just like good things to start recognizing from graphs to get familiar with them. This right here is a quadratic in standard form. That's also what the y-intercept is. So do you see how the y-intercept's at negative 3? That's also something you could have picked out right off the bat as well. So now that you've graphed it, are we shading above or below? Above. So in this case, above is going to be on the outside because it's upside down. Alright, pretty easy lesson today. I'm going to hand out your homework. The key is up on the board if you need it.